Hi, this is the probability data sufficiency video. Um, as you all know, I only will be discussing the solutions of this worksheet. So you all can pause if you have not solved the worksheet given in the description of this video. So solve the worksheet and then look for the explanations in this video. Let's begin. So this is the probability data sufficiency question 1. If a committee of 6 people is to be selected from a group of 20 people, then find the probability of selecting exactly 2 men and 4 women. So we begin with statement A. Um, the number of men in that group is one less than twice the number of women in that group. So we know there are 20 people. Yeah. So men and women make up 20. Number of men in that group is one less than twice the number of women in that group. So this is the expression for the men. So 2W minus 1 is the expression for the men plus W. So this is the expression for the men. And that one is for W. W's W is 20. So 2W minus 1 plus W is 20. So 3W is equal to 21. W is equal to 7. So we know that women are 7. Therefore, men are 13. So with that, we can find out the probability of selecting 2 men. So 13C2 and 4 women. So into 7C4 upon 20C6. Got it? That's your answer. Right. Out of 13 men, how many ways can you select 2 men? 13C2. Out of 7 women, how many ways can you select 4 women? 7C4. So A answers. A answers. So B, C, and E is out. So it's either A or D. Second statement. The total number of women and men in that group is equal to the sum of two primes. So we know that prime numbers begin with 2, 3, 5, 7, 11, 13, 17, 19, and so on. So the total number of women and men in that group is equal to the sum of two primes. Sum of two primes is 13 and 7, which we worked out in A. But then if you look at 17 and 3, that is also a possibility. So we don't know. Yeah. So even if it was 7 and 13, we wouldn't know whether 7 are men or, 13 are men. So B doesn't answer. So therefore D is out. A is the answer. Only A is sufficient to answer the question. Question number 2. From the Venn diagram given below, find the probability of selecting football members only. Football members only. That is X. Okay. Out of a total of 40 members of Press Sports Club, where each member is part of at least one sport. So that means N is 0, where N usually denotes the number of people who are not part of the circle, meaning not part of, in this situation, a member to any sport. Okay. So that at least one sport means all the 40 are within the circles. All the 40 are members to at least one sport, right? Statement A, A, B, C, D, E. All right. We need to find out X upon 40. Okay. Yeah. Number of people who are members of football only is one less than the number of people who are members of all three clubs. So people who are members of all three clubs is Y. So X is one less than Y. Okay. X is 1 less than Y. So let's figure out one more thing from the question stem, that if everything within the circle is 40, then X plus 4 plus Y plus 3 plus 10 plus 2 plus 12 should be equal to 40. So that leaves us with X plus Y equal to 40 minus 4, 3, 7, 10, 17, 17 and 12, 29, 31. So X plus Y is equal to 9. Okay. This is also the information we get from the question stem. First statement tells us this, and we know X plus Y is 9. So we have another relationship. Yeah. With these two informations, these two expressions, we can find out X and Y because they can be solved as simultaneous equations, right? So we will plug in Y as X plus 1. Okay. So X plus Y is 9. Therefore, Y is what? Y is X plus 1 from this expression. So X plus 1, yeah, is equal to 9. So we know it is a 2x is equal to 8, x is equal to 4. So we know x is 4, and we got our answer 10%. 4 upon 40 is 1/10, 1/10 is 10%. So we got our answer, correct? And therefore y is 5. Y is 5. Right. So we got our answer from statement A. B, C, and E is out. Now we have to figure out whether it's D or not. Okay. The number of people who are members to exactly two clubs. So exactly two clubs are these numbers, 4, 3, and 2. Okay. Right. So 4 plus 3 plus 2 is 9. Is 1 less than twice the number of people who are members of all three clubs. Is 1 less than twice the number of people who are members of all three clubs. So then we got 10 is equal to 2y, and therefore y is 5. Correct? And we know that from the first statement we calculated y was 5. So this information is correct. So remember from the question stem, we came to know that x plus y is 9 because we calculated all of them equal to 40. And then we got, if you remember, x plus y is equal to 40 minus 31. If you remember, 31 are the numbers. So yeah. So we know this expression and we know this expression. Y is 5. So x is 4, obviously. So B also answers. So D is the answer. Each alone answers. Okay. Right. Moving on to the third question. It's a coin question. If a biased coin is tossed 6 times, then find the probability that a head shows up at least once. So see, head shows up at least once, could be head, tail, 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 arrangements of these, okay? Head, and then tail, 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 arrangements of these, and then head, tail, 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 arrangements of these, head, tail, arrangements of these, right? So instead of doing all of this, right, all of this, we simply find out arrangements of all tails, right? Because probably that a head shows up at least once, meaning no tail shows up, right? No tail. So when all meaning when all are tails, that is not a part of the sample space out here, right? So then what I'll do is one is a probability that event occurs plus the event doesn't occur. So we are looking for event occurs at least once, right? Right. So if I subtract one minus event doesn't occur, meaning no head shows up. This is no head shows up. Then I'll end up getting the event which I'm looking for, which is the circle part. So that's it. The probability, if I find out this, then I get my answer, right? Yeah. But then we look at statement A and we realize that the probability that a head, it's a biased coin I'm stating. Biased meaning it's a coin which is not a fair coin. So obviously there'll be a difference, meaning it means that the probability of head is not equal to the probability of tail. That is the meaning of a unfair coin or a biased coin. If it was a fair coin, standard coin, or unbiased coin, then the probability of head is equal to that of a tail. Okay. So out here, statement A. So remember, we are looking to find out number of ways, the probability of getting all tails and subtracting it from 1 to get our answer. The probability the head does not show up is 1/5 raised to 6. So uh, this coin has 20% chance that it will show up as a tail. That's what it means. So 1/5 raised to 6 is nothing but this, right? So 1 minus 1/5 raised to 6 gives us the answer for the probability that a head shows up at least once. So A answers. A answers, so it's either A or D. Statement B. Probability of getting a head is 4/5 when the coin is tossed once. So probability of getting a head is 4/5 when a coin is tossed once. So now we know that the probability of not getting a head, which is equal to the probability of getting a tail, is 1/5, right? Yeah, correct. 1/5. So we know that 1/5 raised to 6 from here, and then subtracting it like this gives us the answer. So B also answers, therefore the answer is D. Okay. Let me quickly jot down the answers because I have not yet created the answer key. Hang on a minute. The number of men in the group is one less. Women and men in the group is equal to sum of 2 prime. So one was A. From Venn diagram below, this was, I think, 2D and 3D. Okay. 3 also is D. Okay. Fourth one. If two unbiased dice are rolled once, meaning it's a fair dice. Fair die. Yeah, unbiased. It's a fair die, standard die. If two unbiased dice are rolled once, the sum obtained is denoted by X. What is the probability that the sum is X? Okay. X is an element of a set consisting of even sums. Yeah. Like we know that when two dice are rolled, the sums that we can get is 2, 4, 6, right? 8, 10, 12, and that's it. 6 and 6 is the highest. 1 and 1 is the lowest sum, right? On a dice. Right. So statement A, B, C, D, E. All right. What is the probability that the sum is? Ah, so X is an element of set consisting of all evens. So the probability keeps changing. Suppose if it was 2, then we know that out of 36, only once we get the sum of 2, right? But if it is 4, right? If it is 4, if it is 4, then we have 1, 3, 3, 1. So 2 out of 36 possibilities. So the probability keeps changing. So A is not answering. So A and D is out. Correct? Yeah. Are you getting the picture? X is the element of a set consisting of even sums when two unbiased dice are rolled once. So we know that the sum is denoted by X, but X could be any of these 2, 4, 6, 8, or 10 or 12. Understood? So therefore, we know that we are getting different probabilities depending on what the sum is. So A is not answering. B. X is the element of set consisting of all prime sums when two unbiased dice are rolled once. So prime sums, so between, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and back your I'm sorry, one cannot show up because one is not possible. So these are the sums here we can get. And out of these sums, the prime sums are 2, 3, 5, 7, 11. Okay. 1, 2, 3, 4, 5. So again, the same situation. X is an element of set consisting of all prime sums. So the sum is denoted by X. So if X is 2, then it's 1 out of 36. If X is 3, then it's 1, 2, 2, 1. So 2 out of 36. X is 5, it's 1, 4, 4, 1, 2, 3, 3, 2. So 4 out of 36. You know what I mean? So 1 out of 36, 2 out of 36, for the probability keeps changing. Correct? However, now that we know that B is also not answering and we consider both together, and that together gives us the answer because the common sum between the even and the primes is 2, and there's only one possibility, 1 and 1, and that is 1 1 occurs only once, so we get a definite answer when we take both together. When we know that x is an element of a set of even numbers and a prime numbers, that means the sum obtained is an even prime, which is 2, and only 2 is an even prime number, and therefore we get a definite answer. So answer is C. Food for thought. What would be your answer if you ignore this entire thing, and if you just consider that it's not a data sufficiency question, just a general question? If it was two unbiased dice rolled once, what is the probability that the sum obtained is even or prime? Even or prime. This situation is more like even and prime. Think of it. In the meantime, let's continue solving. Fifth question. Find the probability of obtaining a sum of 5 when two identical biased dice are rolled once. So they are identical but unfair dice rolled once, right? So it is not a standard dice. When you see the word biased, it means it's not a standard dice. It doesn't have 1, 2, 3, 4, 5, 6. But they're asking what is the probability of obtaining a sum of 5. So the probability of not getting a sum of 5 is 8 times the probability of getting a sum of 5. So we know that probability of an event to occur plus the probability of that event not to occur is equal to 1. So out here, the probability of getting a sum of 5 is equal to 8 times the probability of not getting a sum of 5, right? So, so we know that this, correct, is equal to, therefore from here we get P of not 5 or not the event, whatever. So this is not 5, right? Not 5. So not getting a 5 is equal to 1/8 of P of 5, right? Correct. And then we substitute this in this. So we get P of E plus 1/8 of, that is P of 5, plus 1/8 of P of 5 is equal to 1. Correct. So we end up getting 1/1/8 P of 5 equal to 1. 1/1/8 is 9/8 P of 5 equal to 1. So P of 5 we get is 8/9. So we get the answer. What is the probability of obtaining a sum of 5? So A answers. A answers. A answers, C and E. I'm sorry. A answers. So B, C, and E is gone. So now we have to check whether D answers or not. Correct. Each die has faces numbered 1, 1, 2, 2, 3. So we know that when two dice are rolled, right, we end up getting 36 outcomes. Now all we have to figure out that for the event, yeah, 5 to occur, out of these 36 outcomes, how many give you a sum of 5, right? The sum of 5 is not possible with 1 and 2 and 1 and 3. It has to be with 2 and 3 and like that. So 2 goes with 3 with first 2. 2 goes with 3, yeah, the second time, correct? Yeah, the second 2 also goes with 3, right? Right. So this 2 will go with this 3 and this 2 will go with this 3. So we got out of 36, 2 times we got 5. But then we got to remember that it could be 3 and 2 also. Like this is dice 1 and dice 2. Then dice 1 also could be 3 because there are 2 dices, right? And it go with 2 and the same 3 will go with the second 2, right? Yeah. So we end up getting 4 possibilities out here. This 3 on dice 1 will go along with dice 2's 2 and dice 2's 2 out here, right? and dice 1, 2 will go with 3 of dice 2. Dice 1's uh, second 2 will go with the same 3 of dice 2, right? So there are 4 possible outcomes. So B also answers the question, right? B also answers the question. So therefore, both of them answers. So answers D, okay? Yeah. All right. Now, just out of curiosity, going back, uh, is 4 out of 36 1 by 9, right? Right. So what did we get before? We got some 8 by 9, right? So let's just find out what we did of probability of getting a sum of 5. So there's 1 by 9 and 8 by 9. Probability of not getting a sum of, I think the probability of not getting a, we worked it out ulta. So correct. Yeah. Yeah. My bad. My bad. Let me just work this out quickly. Yeah. Hang on a minute. Huh? See, the answer we are getting is 1 by 9. Okay. And that 8 by 9 was misinterpreting this part. Okay. So probability of an event plus the probability of an event not occurring. So we are working out statement A again. Okay. Yeah. Is equal to 1. So probability of getting a 5 plus probability of not getting a 5 is equal to 1. Now here it says probability of not getting a sum of 5 is equal to 8 times the probability of getting a sum of 5. Yeah. And that's it. Then we just substitute. So no more of long calculations that I did before. So this plus, I'll substitute this value out here, correct? Which is 8 times P of 5, which is equal to 1. So 9 times P of 5 is equal to 1. So P of 5 is 1 by 9. Yeah, it does give us the same answer, correct? Yeah, and we worked out D, and D also gave us 1 by 9, 4 by 36, remember? So therefore, D is the answer, okay? Okay. So that was question number 5. Moving on to question 6. From the grid table given below, find the probability that a student is enrolled for biology but not chemistry. Biology but not chemistry. So M is what we need to find out, right? Out of 40. No, out of 100. Out of 100. So we need to find the probability that a student is enrolled for biology but not chemistry, right? So M upon 100 is what we need to answer, correct? All right. From the table, we can make out if this is 100, this is 77. Therefore, X is 20, right? And we are stuck over there. So now this is all the information we get from the table and the questions tab, right? First statement. Number of students enrolled in chemistry. Number of students enrolled in chemistry 77. Acha, chemistry but not biology. Sorry, I'm here. Number of students enrolled in chemistry is one more than twice the number not enrolled in biology. So not enrolled in biology is this, and that is X plus N, correct? So it is one more than twice. I'll just take it as B dash, okay? Twice B dash for the time being instead of X plus N, and one more than that. So 76 is equal to twice of B dash. Therefore, B dash is equal to 38, correct? So now we know that X plus N is 38. So we know this is 62, and then we know M is 5. So A answers the question. A answers the question. So we have to now find out whether D answers the question. Correct? Yeah. Understood this? This is 38. Therefore, from 100, we know this is 62. This is already given as 57. So M is 5. Correct? Now, okay. So we know that this is 77 and therefore X is 20. We have to find out M by 100 from statement 2. Number of students enrolled in chemistry but not biology. Chemistry but not biology is X. So we know X is 20. So number of students enrolled in chemistry but not biology. So 20 is 300% more than the number enrolled in biology but not chemistry. Biology but not chemistry. Biology but not chemistry. So it is 300% more than the number enrolled in. So 300% more. So 300% of M, right? So 20 is 300% more than the number enrolled in biology but not chemistry. So therefore 20 is equal to 300% more. So that makes it 400% of M, right? Why? Because M on its own is 1M. 1M is 100% M, right? That is 1M. So therefore 300% is 3M. So in other words, this is 4M, right? 300% is 3. 3M, 1M, 4M. So M is 5, correct? 20 by 4. So again, we get the same M as 5, 5 by 100. So B also answers the question independently. So A, B, C, D, E, right? A answered, B is also answering, so D is the answer. Right. Hang on, let me just quickly jot down the answers for the fourth, fifth, and sixth. Sixth is B. Fifth is also D. And the fourth is C. Fourth is C. Both together. Okay. Let's move on to question number 7. Okay. A jar contains 3 red, 4 green, P yellow marbles. If two marbles are drawn at random from the jar, so we know it is, what's the probability that both are yellow? So P C2 upon 3 plus 4 plus P C2. This is what we are looking for, right? Yeah. 3 plus 4 plus. So 7 plus P is the total, right? So that is what we are looking for. So statement A. If two marbles are drawn at random from the jar, then the probability that one marble is green and the other is red is 2 by 11. So we know that if two marbles are drawn at random from the jar, then the probability that one marble is green and the other red is 2 by 11. So we know that 3C1 into 4C1 upon 7 plus PC2 is 2 by 11. So we'll try and solve this first. So 3C1 is 3, 4C1 is 4, and this is 7 plus P, correct? Into 7, 6 plus P. So those who are wondering how is it 6 plus P, I'll just show it to you. Yeah. And this whole thing upon 1 into 2, right, is equal to 2 by 11. So let me show it to you. Suppose if it was 4C2 upon, both were green, suppose 4C2 upon 5C2, let's say. Then this is how it would work out, 4 into 3 upon 5 into 4. And that division by 1 by 2 and 1 by 2 on both sides would cancel out, correct? Yeah. So therefore, we know that 5 and then reduces to 4. So I know that 7 plus P would reduce by 1 and become 6 plus P. divide by 1 by 2. Out here, the division of 1 by 2 didn't work because it is 1 and 1, right? So therefore, 12 into 2, that 2 goes up, is equal to, 7 plus P, 6 plus P is equal to 2 by 11. Yeah. So I'm just making sure that it is solvable or not, right? So 12 into 11 is equal to 7 times 6 plus P times 6 plus P. Correct. So I'll need some more space to solve this. Yeah. So I'll just use this space out here. 12 tens are 120, 132 is equal to 42 plus 7P plus 6P plus P square. So 132 minus 42 is 90 is equal to 13P plus P square. So we know that the quadratic equation is solvable. P square plus 13P minus 90 is equal to 0. Factors of 19 using product sum method. 18 and 5. 18 and 5 gives me a sum of 13 if I take plus 18 and minus 5. And obviously, this is minus 90. So if I flip the sign, then P is equal to negative 18 and P is equal to positive 5. So clearly, it can't be a negative one. So P is 5. And therefore, I can get my answer as 5C2 upon 3 plus 4, 7, 7 plus P is 5, right? So 12C2. I get an answer. So A answers. A answers. B, C is out. E is out. Okay? Yeah. Now, second one. If two marbles are drawn at random from the jar, then the probability that both marbles are yellow is 5 by 3 times the probability of both marbles being green. So the probability that it is yellow is PC2 upon 7 plus PC2, right? That both marbles are yellow is 5 by 3 times the probability that both are green. Now, both are green is 4C2 upon 7 plus PC2, right? So from here, this and this cancels out. Yeah. PC2, I can work it out as P into P minus 1, 1 into 2, right, is equal to 5 by 3 times 4 into 3 upon 1 into 2. So again, 1 into 2, 1 into cancels. So I got P square minus P is equal to 3 and 3 cancels, 20. Therefore, P square minus P minus 20 is equal to 0. Now I'll have to work out factors of 20. So 5 minus 5 and plus 4, correct? That'll give me minus 20 and a negative 1. So this is negative 1. Flip the sign. So P is equal to 5 and P is equal to negative 4. So clearly I know that P is 5 and we have already found P as 5 in the previous question. So we know that even B answers the question independently, right? So this was a calculated question. Yeah. And the answer is therefore delta, right? A answered, B also answered. So delta D is the answer. Question 7 was D. All right. Eighth question. If a point is selected at random from a rectangular floor, then what is the probability that the point lies on a circular patch? Okay. A, B, C, D, E. Statement A. Rectangular floor can accommodate 15 identical circular patches wherein 3 patches are conveniently placed end to end along its width and 5 patches end to end along its length. So sorry for the bad drawing. I'll just redraw it. So from the diagram, we can figure out that the circular patches are 15 such that they are touching each other, So I'll have to redraw it because it's difficult. So basically, they are tangentially touching, and that's how we get 15, right? So imagine these are all identical circular patches and they're all touching. So this is all touching, touching, identical, touching out here. So this is what the case is, right? So then can we find out that if a point selected at random, yeah, lies in the circular patch, so the probability that the point lies in the circular patch, the probability of this event is total area of the circles upon the total area of the rectangle. Rectangle, correct? So out here, um, suppose we take diameter as 3, then 3, 3, 3, 3 gives us 15, correct? And 3, 3, 3, 3 gives us 9. So we know that P of E, the rectangular area is 135. Whatever unit you want to consider, centimeter, meter square, are given in statement 2. Yeah, whatever you want. Now we have to take we know that the diameter is 3, therefore the radius is 1.5. So 5 into 1.5 square. So we get a definite answer out, right? Yeah. So we have to find out probability that the point lies on a circular patch is simply these circles together, right? So A answers, right? So now we look at statement B. B, the area not covered by circular patches is equal to 29 meters square. So this portion in yellow, yeah, is 29 meters square. But the problem is that without statement A, this diagram is not possible only, right? Without statement A, we can not deduce this diagram. So we have to only deduce, right, that the area not covered by circular patches is equal to about 29 meters square, right? But we don't know what is the area of the rectangle from the question stem and statement B. Therefore, B does not answer the question, right? We need A to along with B to able to answer, but then obviously A alone can answer. As you can see, A alone can answer because at the end of the day, what is happening is we're getting a numerical answer, and that numerical answer will remain steady to prove my point for statement A. Even if I had not taken 3, right? Even if I had not taken 3 and I had taken, let's say, 5. Okay. So let's say the circles which are 5 in number, yeah. So let's say the diameter is 5. Okay. So you can just try it with one more number so that you get the same answer, right? So then we know that if it is 5, then this is 25 and this is 15. All right. So 15 into 25 is my total area of the rectangle. And then the radius would be 2.5, right? Because we are taking the diameter as 5. So square that. So now all you have to check is this portion equivalent to this portion, right? So it's easy. 2.5 into 2.5, right? So uh, we multiply this by 100 and this by 100 to get rid of the decimal. So 25 will go into this 4 times, and this 25 and 25 cancels. So we get pi upon 15 into 4, right? Pi upon 15 into 4, correct? Yeah. Okay. And this one if I take 1.5 into 1.5, yeah, and then multiply by 100, then this becomes 15 and 15. So 15 goes into this 9 times. 3 threes are and 3 fives are, and 5 goes into this 20 times. So pi by 60 again, and this is also pi by 60. So yeah, A answers a a steady ratio of pi by 60. Yeah, A gives us a steady ratio of pi by 60. Now, obviously, there's one more information that I forgot. Uh, this is total area of the circle, so it should be into 15, and this also should be into 15. So 15, 15 cancels, so we end up getting. Sorry for that. We end up getting pi by 4 both the sides. Yeah. Okay. So do the math again if you want. Yeah. I'll just give you that B doesn't answer. A answers. Therefore, A is the answer. But I'll just neatly write down the statement. Yeah. Here it is. So probability of the point being in a circular patch is area of all circles upon the total area of the rectangle. So if we were to consider 3 as the diameter, then 1.5 is the area of one circle, radius of one circle, right? But then we have to multiply it by 15 because there are 15 circles if we take, you know, 15 identical circular patches upon the total area. So with diameter of 3, three circles in the width and 5 circles in the length. So that is 15, 15 as the length and 9 as the width. And when we solve this, we'll end up getting pi by 4. That's what I was trying to tell you. That 15 I forgot in my previous calculation, and it was all very messy. So my apologies. Bear with me. Yeah, for the untidy thing. Yeah. Anyway, so eighth question we know B doesn't answer. A was the answer. So let me write it down. Eighth is A. Ninth one. If a five-letter word contains exactly two vowels, yeah, then what is the probability that it begins with a vowel? Right. Consider all letters have the same font size, same font, and are all in small case of the English alphabet. So we know that if there are five letters, let's call them A, B, C, D, E. Then there are 5 factorial ways to arrange them. Correct. But then we don't know. Yeah, we don't know the two vowels. It begins with two vowels, right? So suppose the word is begin, then we know that it will be E and I, and the remaining four dashes could be 4 factorial ways to solve them, meaning 4, 3, 2, 1, right? So that would be the answer. But then we don't know whether the two vowels are identical or not. So A answers that both vowels are the same letter. Now both vowels are the same letter, correct? Then we could take an example as digit. All right. So with digit, the same letter I can be grouped and D, G, T. So we have 4 factorial ways of solving it. But the question is, do we have any non-vowels repeating or not repeating? We don't know that from A. So A cannot answer because we don't know whether the DGT, if there's a word where it is like, something like array. So two vowels are same, but are the two consonants also same or not same? Is it this or is it this? We don't know. So A doesn't answer, D doesn't answer, E is out. Sorry, E is read in. So it's B, C, and E remaining. Okay. Second statement, the number of ways the letters of the words can be arranged is 5 factorial by 2 factorial. So we know contains exactly two vowels. We know that the number of ways the letters of the word can be arranged is 5 factorial by 2 factorial. Correct? So with 5 factorial, if two letters are repeating, so let's say if it was, um, digit, how many ways to arrange letters of the word digit without the constraint that it begins with a vowel or does not begin with a vowel? Just how many ways to arrange digit? So we know the number of ways to arrange digit is 5 factorial by 2 factorial. So from the second statement, we know that two letters are repeating, but we don't know whether the two letters are the vowels repeating or vowels not repeating. Or it is, we don't know whether it is Titan where the vowels are different, but the T letter is repeating. So we don't know whether it's Titan or it is digit, whether two I's are repeating or whether the two consonants are repeating. So statement B also doesn't answer. But when we take both together, we know that the vowels, there are two vowels and they are the same letter. That means the vowels are repeating. So it is most probably this situation, right? With 5 factorial by 2 factorial, it is this situation, right? And hence we can see that it begins with a vowel. So the number of ways to arrange these four is 4 factorial. And the two i's are the same. So, ideally it would be into 2 factorial by 2 factorial because the two i's are repeating. So this part is not required, it's only this. All right. So yeah, C is the answer in this situation. A very complicated question, to be honest. And the last question now. Okay, let's quickly finish this worksheet. A manufacturing unit rejects a block if any part in that block is defective. A block consists of some parts. What is the probability that the block will be rejected? So this is again a case wherein, yeah, the probability that a part is defective is 10%. So see, this is a case wherein, uh, you know, probability of an event to occur plus the probability of that event not to occur is equal to 1. Understood? Yeah. So out here, let's understand that if it is defective, right? Yeah, right. Any part in that block is defective. So it was like, uh, so this is a block, yeah. And let's say there are six parts, like that tossing the coin case. So if any one of them is defective, then the block is, I mean, any part is, uh, the block will be rejected if any part is defective, right? So it's either one part which is defective, two parts which is defective. So it is a situation where you have defective, 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 defective. So one defective and the rest are not defective. It is rejected. Are you getting me? Yeah. Then we have two defective and four not defective. So instead of finding out, three defective, three parts are defective, yeah, and the other three are not defective, instead of that, we simply find out all are not effective. That means it is not rejected. Correct. All six parts are not defective. That means it is not rejected. Correct. So we are trying to find out whether it is defective. So one minus the probability that it is not rejected. Yeah. Right. So let's say this is P of D, meaning defective and not defective. So the not defective is equal to 1 minus probability that it is defective. Correct. Right. Correct. Right. Or probability, sorry. Yeah. Correct. So the probability that it is defective is 1 minus the probability it is not defective. So this is possible. Yeah. So we'll need to find out now. Statement A, the probability that a part is defective is 10%. Correct. So, but we don't know there are how many parts. One, two, three parts are there, four parts are there, five parts are there, six parts are. We don't know that. Understood. So I've taken six parts an example, but we don't know how many are there. So A alone cannot answer. Okay. Yeah. Now B statement tells us the block consists of four parts. So if it's 4 parts, and if we find out that it is not defective, correct? But then we don't know the probability of being defective or not defective, right? We know that there are 4 parts. Now we know that the block consists of 4 parts. But out of these 4 parts, we don't know what is the probability of it being defective or not defective, which only A gives us. So B alone doesn't answer. When we take both together, we know that the if it's defective, it is 10%. If it's not defective, it is 90%. 90% is 9 by 10. So 9 by 10, 9 by 10, 9 by 10, 9 by 10 for all of them will give me the probability that it is not defective, correct? So that is 9 by 10 raised to 4. And that if I subtract from 1, I'll get the probability that it is defective and the block will be rejected. Therefore, C is the answer, both together answers. Okay. And that's it, guys. Thank you very much. Remember for a full review of probability, uh, look for the links given in the description of the video. Yeah. Thank you very much.